2023 ADMA paper 2 question 9. The diagram shows part of the curve y is equal to 6 square root of x and part of the straight line y is equal to 3x intersecting at the point O and T. Find the coordinates of T. So to find the coordinates of T, you can simply solve these two equations simultaneously. Y is equal to 3x and y is equal to 6 root x. So you can use substitution, you can use elimination. I'll use substitution. So I'll substitute this in there so that you have 3x is equal to 6 root x. And then at this point, I will square both sides. Maybe before I square, I can divide through by 3 so that I reduce my numbers. This is much easier. And then to solve for x, I can square both sides to get rid of the square root. So this one will be x squared. And then when I square there, this square will affect both numbers in the bracket. So this will be 4, and then this x squared will be like the square root of x squared, and then this and this will go. So we have this. And then when I take the 4x to the other side, please don't divide both sides by 4x or maybe by x. You will lose one of the values, despite the fact that it may not be required here. So you can use factorization methods or any other method of solving quadratic equations. So factorization is easier. I can just factor out an x, then I have this. So either x is equal to 0 or x minus 4 is equal to 0. So x will be equal to 4. So we can say now to this, because this is equal to 0. I mean, you can't have a 0 there. So the two are meeting at two different points, this point and this point. So the 0 is for this. We don't need the coordinates of this. We know that this is 0, 0. So our x coordinates are x 0 or 4. So now let's find the y coordinates. No need to use the 0. So I'll use the first equation and my x is 4. So this times this will be 12. So that means the coordinates are 4, 12. 4, 12 are the coordinates of T. And then find the volume generated when the shaded region is rotated through 360 degrees about the x-axis. So in this case, this has been rotated about the x-axis. So you integrate with respect to x and then you get the x coordinates. But if it was rotated about the y-axis, make sure that you integrate with respect to y and use the limits from the y-axis. So in this case, we can say volume. Of course, we shall have volume generated by this straight line when rotated, which will be something like this. I've just decided to draw it upright. Let me just put it like this. And then we'll also have the volume of the bigger thing there, which will be something like this. So to find the shaded volume, you can say volume is equal to pi, the integral from 0 all the way to this point there. We know that x is 4 at that point. And then the bigger function here is this, because it's the one on top. So you integrate. Remember, this is the formula. Let me just write it down. Y squared dx. So the function there is 6 root x squared minus pi, the integral from 0 to 4 of the straight line, which is 3x, don't forget the square, dx. So now our v will be, we can just factor the pi and these things out. So this will be like, when you square this, you have 36. Then when you square the square root of x, you simply have an x, since this will cancel out. And then when you square 3x, you have 9x squared dx. So I've just factored out pi and the integral from 0 to pi to combine the two. So v is equal to pi. Let's integrate this. This will give us 36x squared over 2. So 36 over 2 is 18x squared. Then this will give us 9x cubed over 3. Remember, the power is increasing by 1. So 9x cubed over 3. So this will give us 3x cubed from 0 to 4. So v will be 18 multiplied by 4 squared minus 3x, actually 3 to the power 3 multiplied by 4 cubed, then minus, when you put zeros there, you just get another 0. So v will be equal to pi, a bit of calculator work here, 18 multiplied by 4 squared, so this will be 288 minus 3 multiplied by 4 cubed, so this will be 192. So that our v will be 288 minus 192, which is 96 pi. And then remember, this is volume, so you must have units with a cube. So we are done.